Have you ever wondered about the fastest spinning star in the universe? In the vast cosmic theater, stars take on many roles. Some are the familiar, comforting glow we see at night, while others are the stuff of science fiction nightmares. Among these celestial actors, few are as fascinating or as terrifying as pulsars. Pulsars are neutron stars, the tiny yet incredibly dense remnants of massive stars that have ended their lives in spectacular supernova explosions. Imagine a star more massive than our sun but so dense it could fit within a city like New York or London. That's a neutron star. But pulsars are not just any neutron stars. They are the spinning tops of the cosmic playground, spinning at breakneck speeds and sending out beams of radiation into the universe. These beams, powered by the pulsar's intense magnetic fields, sweep across the universe like the beam of a lighthouse. And just like a lighthouse, they serve as cosmic beacons, their steady pulses of light helping astronomers probe the mysteries of the universe. The magnetic fields of pulsars are 1,000,000 times stronger than the strongest magnetic field ever created by humans. This intense magnetism, combined with their extreme density and rapid rotation, makes pulsars some of the most extreme objects in the universe. But don't let their size fool you. Despite being only a few miles across, pulsars pack a mass greater than that of our sun. Their surface gravity is so strong that a marshmallow dropped onto a pulsar would hit the surface at a speed of nearly 1,000 miles per second. As we journey through the cosmos, pulsars serve as a reminder of the incredible diversity and extreme conditions that exist in our universe. They are testaments to the power of gravity, the immensity of mass, and the relentless march of time. If you're ready to dive headfirst into the world of these cosmic lighthouses, then buckle up. As we delve deeper into the life of these celestial sentinels, we'll explore their birth, their life, and their eventual death. So stay tuned as we delve deeper into the life of these cosmic lighthouses. So how does a pulsar come to be? Our journey begins with a star. Not just any star, but a massive one. One that's at least 8 times the mass of our own sun. In its heart, a ferocious battle of nuclear fusion is taking place, creating heavier elements from lighter ones. But, like every good thing, this too must end. When the star has created iron in its core, the nuclear fusion grinds to a halt. Without the outward pressure created by this process, the star can no longer fight against the inward pull of gravity. And so, the star collapses under its own weight, triggering a supernova explosion. This is no ordinary explosion. It's one of the most powerful events in the universe, outshining entire galaxies for a brief moment. But what's left in the wake of this celestial fireworks show? A core, stripped bare, made up almost entirely of neutrons. This is a neutron star, an object so dense that a teaspoon of its material would weigh about 1,000,000,000 tons on Earth. Now here's where things get even more interesting. Remember how ice skaters spin faster when they pull their arms in? That's due to the conservation of angular momentum. The same principle applies to the neutron star. As the star's core collapses, it shrinks in size, but its rotational speed increases, causing it to spin incredibly fast. This spinning neutron star generates a powerful magnetic field. Charged particles in this field are accelerated to nearly the speed of light, emitting beams of electromagnetic radiation. When these beams sweep across our line of sight like a cosmic lighthouse, we see a flash of light. This is a pulsar, a cosmic beacon flashing its rhythmic signals into the universe, and thus a pulsar is born, spinning wildly into the cosmos. But how long does a pulsar live and what happens when it dies? The lifespan of a pulsar is as fascinating as its birth. Pulsars can continue their rapid spin for millions of years, their existence a cosmic ballet as they twirl tirelessly in the vast expanse of space. Yet, like everything in the universe, they are not eternal. Over time, they begin to lose their energy, their spins gradually slowing down. This process, known as spin down, can take anywhere from a few thousand years to several billion, depending on the pulsar's initial rotation speed and magnetic field strength. As a pulsar slows, it enters a new phase of life. Some pulsars become magnetars, stars with the most powerful magnetic fields in the universe. These fields are so intense, in fact, that they can rip atoms apart and cause starquakes, releasing more energy in 1/10 of a second than our sun does in 100,000 years. But what about the pulsars that don't become magnetars? Well, their fate is no less dramatic. If a pulsar is massive enough, it may collapse under its own weight to form a black hole, an object so dense that not even light can escape its gravitational pull. These black holes become cosmic vacuum cleaners, swallowing up any nearby matter and warping the fabric of space and time itself. Yet, regardless of their end as a magnetar or a black hole, the journey of a pulsar is one of cosmic significance. They are not just spinning tops lost in the universe, they are cosmic lighthouses, their beams of radiation serving as some of the most precise clocks in the universe. They help us probe the mysteries of space and time, and even aid in the detection of gravitational waves. So the next time you gaze at the stars, spare a thought for these magnificent cosmic metronomes. Their life and death serve as a reminder of the universe's constant evolution, the endless cycle of birth, life and death that rules all things, from the smallest atom to the largest galaxy. As they say, even stars must face their twilight. What would happen if you got too close to a pulsar? Well, let's just say it's not a trip you'd want to book anytime soon. Pulsars, these cosmic lighthouses, are among the most extreme objects in our universe. They're not just spinning stars, they're spinning stars with a gravity so intense that it can crush an object down to an infinitesimally small point. This is known as singularity, a place where our understanding of physics breaks down. Imagine standing on the surface of a pulsar. You'd weigh about 1 billion times more than you do on Earth. But don't worry, you wouldn't be there for long. The immense gravitational pull would tear you apart before you could even blink. This process, fittingly known as spaghettification, would stretch you into a long, thin string of atoms. But the gravitational pull isn't the only danger lurking around pulsars. They also emit lethal levels of radiation. As they spin, they shoot out beams of energy that could vaporize any living thing in an instant. This radiation is so powerful that even from a distance of thousands of light years away, it can disrupt the electronics on our satellites. And then there are the magnetic fields. Pulsars possess the strongest magnetic fields in the universe. To give you some perspective, the magnetic field of a typical pulsar is 1 trillion times stronger than that of Earth. If you were to get too close, the magnetic field would be so powerful that it could strip the electrons off your atoms, effectively turning you into plasma. So, getting close to a pulsar? It's a one-way ticket to oblivion. They're fascinating to study from a safe distance, of course. Their existence tests the limits of our understanding of physics, but up close, they're nothing short of deadly. In the face of a pulsar, not even light can escape unscathed. Now meet PSRJ 1748-2427b, the fastest spinning star in the universe. This is a pulsar that takes extreme to a whole new level. Located in the constellation of Sagittarius, this pulsar is a celestial object of fascination and wonder. Pulsars, as you've learned, are remnants of massive stars that have ended their life cycles in supernova explosions. But what sets this star apart from the rest is its extraordinary spin rate. Imagine a star spinning over 700 times per second. That's right, 700 times. In the time it takes you to blink, this pulsar has spun around hundreds of times. To put that into perspective, it's spinning faster than a dentist's drill. In fact, it's spinning so fast that it's pushing the very limits of what we thought was possible. The speed at which PSR spins is so extreme that it challenges our understanding of physics. According to our current understanding, if a star spins too fast, it should break apart due to centrifugal force. Yet PSR defies this, spinning at over 1/4 of the speed of light at its equator without tearing itself apart. This pulsar is not only a super-fast spinner but also an incredibly dense object. Picture a mass greater than that of our sun, compressed into an area with a diameter of about 20 kilometers. That's like cramming Mount Everest into a thimble. Despite its small size, the gravitational pull of PSR is immense, about 300 billion times stronger than Earth's gravity. If you were to drop a marshmallow from a height of 1 meter on this pulsar, it would hit the surface in a microsecond, reaching a speed of over 4 million kilometers per hour. In the vast expanse of the universe, PSRJ 1748-2427b truly stands out, reminding us of the wonders that lie beyond our world. This pulsar, with its extreme characteristics, continues to puzzle and fascinate scientists, driving our desire to further explore and understand the mysteries of the cosmos.